So number 11 and 12 is all about forces, 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 and you really shouldn't be freaky about forces, because really, what is a force? It's all about a parallelogram. And if we know our properties of parallelograms, then we're going to know how to do force questions, remembering that the opposite sides of a parallelogram are congruent. So opposite sides are congruent. They're also, since it's a parallelogram, they're also parallel. So opposite sides are both congruent and parallel. Opposite angles are congruent. So angles that are across from each other are congruent. And consecutive angles or adjacent angles are supplementary. So their sum adds up to 180. So if this were 50, this angle over here, excuse me, would be 130, etc. The fact that opposite sides are parallel, you want to also look for that z, that congruent alternate interior angles. So this angle over here is going to be congruent to this angle over here. But I got to tell you that this is the key right here, knowing that consecutive angles are equal to 180, and also knowing that when this resultant is drawn, this resultant force, this is an original force, this is an original force, this diagonal represents the resultant force, or the magnitude. Magnitude, a lot of you get scared by. Magnitude means length. Just substitute the word length, and when they say magnitude, and you won't get freaked out about it. That this diagonal separates this parallelogram into two congruent triangles. So once I have everything labeled, I could just focus on one of the triangles and use, of course, one of my triangle laws, either law of sines or law of cosines. If there are angles all over the place, law of sines. If there are sides all over the place, law of cosines. But one of the biggest misconceptions in any parallelogram diagram is students think that this diagonal will bisect this angle. And if this happens to be 100, that these would be 50 apiece, and that's not true. The only time that that would be true is if these two forces were an equal magnitude, an equal poundage, if you will, just a measure of exertion. If these two forces are congruent or equal in measure, then this would be a rhombus, and these two angles would be congruent. Now, in question number 11 and 12, that wasn't the case. They were both just plain old parallelograms. And this is what the force diagram looks like. This is a vector. This is a force. This is another vector. This is the body that we're acting on. This is the resultant force right here. It's coming out of the body here. And you can draw the diagram like this. It's perfectly fine. You'll get full credit for it. Or you can draw the diagram like this. But if you draw the forces, connect it as if it were a parallelogram. So they tell me the original forces. They tell me the angle between the two forces. And they want me to find the magnitude or length of the resultant force, which is right here. So I'm going to put a big old X. So what you want to do is fill in everything you know about the sides and angles before I dive into this problem. So I know opposite sides are congruent. And I know that I will not be able to use that 100-degree angle. I mean, think about it. Once I'm using a triangle law, and I cover that up, do I have the 100-degree angle? No, I don't. And a lot of you on your test, your apps test, put like a 50 here, which isn't true. Or on your practice regions test, put a 50 here, and it's not true because these are not congruent. This is not a rhombus. So you need that consecutive angle. You need that supplemental angle, which happens to be 80. So this is 100, this is 100, won't need it, but I do need those 80s. So when I cover this up, and I look at that triangle, it's all about sides, right? It's all about law of cosines. So I start with the angle involved, and I go across, and I start with x squared. So when I put this into the law of cosines, again, that suggestion is type this in one shot. Do not do it in pieces. There's no embedded variables in here. It's completely unnecessary to type it in pieces. It's not going to get you more credit, and you might make an error. So then you take the square root of both sides, and you get your 47.97. So that is the magnitude of the resultant force. Now, with number 12, same thing. You can draw the parallelogram if you want. You can draw the force diagram if you want. In this particular case, they didn't give you the magnitude of the forces. They did give you the magnitude of the resultant force, which was 24 pounds. They gave you the angles formed by the forces and the resultant are 50 and 35 degrees. So they want the measure of the larger force. Now what students have done in the past is they don't know which one's larger. They might find both of them and just box the larger one. But let's talk about which one is indeed larger. So what can we mark in on this diagram? Well, I know that these are alternate interior angles, so these are 50 apiece, and these are 35 apiece. And I know because this adds up to 85 when I add the 50 and 35 together, that the relationship between the angle between the two forces and this angle is going to be a supplemental relationship. So I put the 95 in there. And of course, since the opposite angles are congruent, I put the 95 in there as well. So now, which one would be bigger? Well, this force is opposite a 50-degree angle. And this force is opposite a 35. You'd be like, D'Amato, this isn't a force here. But these two sides are congruent. So if I just focus on one triangle, I'm going to focus on the bottom one here. It doesn't matter if I focused on the top. That this side had to be bigger than this side. Because in a triangle, the side opposite the bigger angle will indeed be bigger. And just by eyeballing this, since this is a 95-degree angle, it's definitely going to be smaller than 24. So this indeed is the bigger force. Okay, so all about angles, angles, angles here, correct? So if I cover up that part, you can see I just have one side. I have to use a lot of signs. So it's going to be x over the sine of 50 equals 24 over the sine of 95. Cross multiply, and I get 18 point and change to the nearest integer. I don't know if it said rounding, so I'm just rounding it to the nearest integer. Just the question would have said round to. I probably just wrote that one myself, and you get your 18.